My name is David Jakl. I am technical marketing engineer in service provider business unit. In the access part of the BU, I am focusing on the 5G and end-to-end service provider architectures, and primarily focusing now on NCS 540 router. So actually I joined Cisco in 2006. I spent like 11 years in sales, being systems engineers in Europe, and then I joined the business unit, and I started with 5G and Jakl solution or transport strategy and evolution, and now I moved to really focus on the key component in the 5G architecture, which is the NCS 500 series, and namely NCS 540. So this is the NCS 500 series. This is the Cisco's next generation service provider access portfolio, access aggregation portfolio. But it's not just for service providers. We also have a lot of customers in enterprise, and especially in utilities. We introduced this portfolio last year at Mobile World Congress in Barcelona, introducing like 3 flavors, so 3 members in the family itself. There is NCS 520, which is which runs iOS XE, so not iOS XR, but iOS XE. This is positioned as an access switch or NIT for, let's say, traditional service provider customers. Then you have fixed platform NCS 540 and NCS 560. Both runs iOS XR. They are again having DNX chipset, so Broadcom DNX family. So I will talk more about the features, but more or less with certain small exceptions, there's feature parity between 540, 560 and the NCS 5500. So, and we built this portfolio having 5G in mind, especially 5G in mind, to like focused on security, focused on low cost, focused on low power consumption, of course high density, because 5G and the new networks are about the growing bandwidth. And of course these platforms have to be deployed sometimes in very, let's say, remote areas like outdoor cabinet in all parts of the world with very humid conditions and very temperature-rich conditions. So they have to adapt and be used in these parts of the world. So, where to position and how to fit, how we are positioning the platforms. So, it's okay. Primarily, these were built for mobile backhaul, but not just this. Okay, traditional carrier Ethernet is also this segment. Then, okay, for cable providers, remote PHY especially. So with remote PHY, we are like the MSOs networks are being simplified and being built with Ethernet and traditional IP-based transport down lower to distributed towards the remote PHY units. So this is where we fit with our platforms. And also for sure FTTX is what we are designing and where we are positioning our NCS 500 portfolio. And this is the access, so we're like connecting the access technologies directly to the routers. Or we definitely like position the platforms in the pre-aggregation, aggregation, or in the, let's say, low PE segment of the network. 5G. So what we are having in mind is 5G and its requirement. So there's a huge requirement on throughput for sure. So we are talking about like that we need to connect base stations not with 1 GE, but with 10 GE or soon with 25 GE interfaces. So then, of course, you need at least 100 GE uplink from that cell site. Latency is critical. As Phil mentioned, we need, there are use cases in 5G for say, gaming, so really lower the latency as much as possible, as well as, for example, the kind of sci-fi, but remote surgery or some medical applications that might be also possible, but we need to build the networks and the routers with lowest latency possible. We cannot do anything with the transport, with the light transmission speed, which is the 5 microseconds per kilometer, per 100 kilometers, sorry. So latency is key. Synchronization also, because 5G by design, it needs all the base stations, they have to be extremely well synchronized. So we are talking about let's say devices with class A, class B, and latest with class C quality of synchronization, and we are building the products with class C recently. This is part of our recent announcement. So that was already covered, but yes, all the devices have to fit to our end-to-end architecture for service providers, again, not only for service providers. So segment routing end-to-end, BGP-based services, L3 VPNs, and EVPN for L2 or combination L2, L3. So, okay, now, having like 520, let's take it like separately, but 560, 540, we do have solution with iOS XR end-to-end, really from remote location, outdoor cabinet to data center with iOS XR as well as 100 gig. The solution is validated. Phil is like part of the team who is like really looking at validating and preparing the solution to fit the largest networks in the world. Currently, we have the largest network in the world in India. Has like more than 200,000 devices, and it's following our architectures. There's architecture. There is not segment routing yet, but we are going there with exactly this solution. Okay, the new portfolio, how it fits into what we had before. So maybe some of you know the SR900 series, so it's still there. We are not going to replace it with 500 series, so especially because 500 series is only about Ethernet, so there's no TDM interfaces. So there are still a lot of customers, a lot of service providers who need the TDM interfaces and the way to migrate the TDM to IP. So for them, it's NCS 900 series as well as NCS 4200. So access 520, 540, 560 in aggregation or pre-aggregation, aggregation, and all what you know 900 series remains, and then we have 9Ks and 5500s in the edge core aggregation, big aggregation and peering. All right, so how it fits to how the iOS XR portfolio as such looks like today. So on one side we have the virtual XR, which runs on x86 servers. That's something which exists for quite some time. Then we have our traditional platforms with the custom silicon like SR9K, 6K, CRS. And then the middle, that's what Peter mentioned, that's the merchant silicon-based, cost optimized, performance optimized, power consumption optimized, simplified architecture, where we also have the 540, 560 with the DNX family, the Broadcom DNX family chipset. All right, quickly on 520. So 520, it's not iOS XR. It is Broadcom again, so it's another family of another chip from Broadcom, 60 gig Saber 2 chip from Broadcom. This is the NIT with lower amount of interfaces, and like the switch with more interfaces. It's up to 10 gigis. It's really meant to replace ME3400E in the service provider networks, focusing on security, timing features for synchronization, and for, let's say, again, we have the conformal coated variants. For humid conditions, we have AC/DC power supply variants. And like, yes, the key is security, and the feature set as such is like primarily L2, but also like simple V4, IPv4 unicast routing is there as well for actually there's the parity with ME3400. And CS540, so this is primarily what I'm focusing on every day. So these days, that's really the smallest and cheapest iOS XR router in our portfolio. Only 25 centimeters deep. So say it's really universal converged access aggregation router. So any application, feature-wise, again, DNX family. So parity, primarily 4G, 5G cell site router, but there is a lot of interest in non-SP, from non-SP segment, like especially the utility customers and universities. One of the earliest users or deployers of 540 or some universities in Germany. So I forgot to mention that all the 500 series family is MEF 3.0 certified, so fully all three. Some details. So the platform is really iTemp, so designed to conditions -40 to +70 degrees Celsius. We have modular power supplies, AC or DC. It's 540 is front to back airflow. Power consumption is key, so we are somewhere between 100 watts and 200 watts. It has integrated GNSS receivers, so you can get your synchronization from the satellites. But recently, there are still some discussions on how to protect, because you can easily harm the reception of the GNS of the, say, GPS and other satellite transmissions. So there are ways to really get the synchronization from the wires, from the optical fibers. It has Intel processor. The performance is 300 megapackets per second and minimum of 300 gigapackets per second. But again, there's a Qumran AX ASIC and huge external buffer to buffer 80 milliseconds of traffic. For the interfaces, there will be graphical slide later on, but it's extremely universal. So we can support from 10 megabit Ethernet copper up to 100 gig interface with the reach of 40 kilometers. The latency, again, key as I mentioned. So this ASIC and this simplified architecture allows us to really get below 10 microseconds of latency in all cases, in any case. And okay, we also need, because we are somehow distant, we need DWDM and Centaur optics support. That's there as well. So how it looks, so we have 24 10 gigis. So it can have 10 meg, 1/10 gigi, then 8 25 gigis, which you can also plug 1 or 10 gigis there, and 2 QSFP28 with 100 gigi, which can be, these QSFPs can be breakout to 4x25 or 4x10. It also supports 40 gigi, but 40 gigi, as this is really data center technology, and in service provider networks, 25 gigi is big thing. We are certifying these days new transceivers to support bidirectional, the single fiber optics, tunable DWDM optics on 25 gigi. So this is where the most development is done in our part of the network. So there's the GNSS antenna, GNSS, let's say the timing interfaces to get the synchronization or to provide the synchronization and power supplies. Okay, what's new? We are this month we are expanding the NCS 540 family with 4 new flavors, 4 new variants. These are left side AC powered, on the right side DC powered. So we have, with the new family, we have to bring down the cost and to optimize the cost. We have fixed power supplies, so that's how it's split. So we have two more 300 gig variants and 2 140 gig variants. 2 of them, these 2 are focused primarily on the mobile backhaul solution, because for certain application or for, let's say, legacy base stations with 1 gig, you need to provide there are like copper interfaces towards certain base station vendors, and you need to provide synchronization over the copper interface, and that's the reason why these 2 variants, they have built-in copper gigis or 100 gigi copper ports to provide the synchronization, because you cannot deliver SYNC over SFP on like copper SFP. Okay, this new family is called Big Band. So the reliability will be turned on this month with FCS in July. So there are some differences. So up to 400 gigis in this Crater Lake. For the new variants, we will have Class C precision. You can see that we lowered the amount of memory in the new variant, because with iOS XR7 we built like the newer version of XR, which has much less, just like simplified infrastructure, lightened infrastructure. So we are able to run it on only 8 gig memory. So again, bringing down the cost.
I have a really dumb question. And I'm so used to having replaceable power supplies in everything I order, right? Is there a huge cost saving in going with a fixed power supply and then having to maintain 2 separate models with different power supplies in, versus, even if it's just a single power supply, having something that's replaceable?
Yeah,
is that something people are asking for? I don't know.
For what I know, that the cost, you need some more space if you have modular power supplies, and the cost is really higher with the modular ones, and the MTBF itself of the today's like power supplies is quite high, so we don't not worry about the, let's say, the failures of the power supplies.
Fair enough. Thank you. I'm genuinely interested. So.
Yeah. So just for your information, look, what Class C means in precision, in timing precision, it is plus minus 10 nanoseconds of precision in time synchronization. So you need this level of precision for the node in order to build a network in certain size, in order to really run the 5G, the most, let's say, advanced 5G technologies. So it's really something what we need to deal with. This is not about networking. This is really something like special. We need special teams to look at. The feature support. So yes, there is like everything. So we need to have some legacy features for the traditional SPs, because they are sometimes very conservative in moving forward. So things like RSVPTE or LDP are there. For services, okay, traditional VPNs, but EVPN for the new, let's say, new providers. For multicast, okay, we are building especially the MVPN or some multicast solution with segment routing, but we also need to build, and this is what we are building now. For example, the legacy draft Rosen multicast features, which is now not on DNX, but will be soon. So then, okay, focus on security, for sure, like QoS, even the merchant silicon, the Broadcom, is not, let's say, it's limited in certain aspects compared to our custom-built ASICs, like which we have in SR9K. It still has great QoS, great HQoS support. So 3 level of HQoS we can have even on this small platform. So that was 540, 560. That's again up to 100 gig platform, module 1 with centralized RSP. Maybe you know this because this is SR900, and we actually built new RSP for SR900, which we then call NCS 560. So this is RSP4. Previously we started with RSP1 with 55 gigs, RSP2 with 128 gig, RSP3 with 200 or 400 gig, and now this is RSP4. Again, it's not custom, it's DNX Qumran MX with 800 gig of throughput. So it is modular, but still centralized forwarding. So there is single forwarding chip inside. We have 2 flavors of the RSP4s to handle bigger scale. So with the bigger scale, we typically, or what the focus is on prefixes. So with the higher scale, with the external TCAM, we can get up to like 2 billion V4 prefixes. So we have the original, let's say, SR900 chassis with 16 IM modules. Yes, the customers can use the older SR900 series interface modules and only the Ethernet ones and plug it in. And of course, we need some more density in 100 gig. So this is the new module we introduced. So 2 by 100 gig with QSFP interfaces. What's new? This is the 4RU chassis, which we recently started shipping. That's for 6 interface modules, again 800 gig capacity in total. We have, and it's like, okay, the number is there for the number of rack units. So, and both are again like industry temperature hardened, so up to 65 degrees Celsius with, again, this is the IM with 200 gigs. And the features are the same, actually features with as for 540. What's special on 560 as well is that you can plug 2 RSPs inside, and there is the ISSU support. So you can have the RSP redundancy, you can like have in-service upgrades with minimal, let's say, service impact. All right. In summary, so NCS 500 series, not only SP for all customers, temperature hardened, having 5G in mind, power cost optimized, iOS XR on 540, 560. This is 60 gig platform, this is 140 or 300 gig platform, and this is 800 gig platform. Fully aligned with Cisco end-to-end converged SDN transport. So again, 5G is the key driver building convergent networks for any service provider or any customer. We're providing, like we have pay-as-you-grow options to even lower the cost, programmability, telemetry. So everything what's like applicable for the DNX family is, and iOS XR in general is there.